Hello everyone, this is Santosh. Welcome to TechDesign. So I'm going to start a series of videos on NX CAM applications. So this series is going to be start from a basic to advanced level. So even if you don't know anything related to CAM, if you are doing just a part modeling and surface modeling, you can able to understand how NX CAM works and how we can make a computer aided manufacturing. Okay, so the first couple of videos will be on a presentation, so I'll be just giving you some introduction about NX CAM and then the terminologies that we need in NX CAM applications. So once that is starts, we are going to go into NX application and then we will see how we can do NX CAM. So since this is the first video, I'm going to start from the introduction on an XCAM. And now you can see what is computer aided manufacturing. So we also call it as a CAM. Okay, so it is the tool that helps to control and automate the production of goods by translating a digital signs into instructions for machines. So whatever the 3D model that you are going to create in part modeling or surface modeling or any other modeling, so that will be converted into instruction. So instruction for a machines to manufacturing. So that is what the CAM application do. And you can see here it works by taking a design created in CAD software. So whatever the CAD softwares you will use, maybe SolidWorks or Solid Edge or Creo or NX application, whatever the CAD software you use, so that will be whatever the CAD model that will create, that is going to be an input for our CAM. Okay, so we just any other material, so we just need a CAD model, maybe it is a part model or surface model or anything, so that is going to be an input for our CAM application. So it generates a tool path and machining instruction which the machine can understand to produce a physical part with increased precision, efficiency and quality. So what does it do when you do a CAD model and you take it to a CAM application and you do it will create a tool path for machining instruction, so in order to create a physical part with a increased precisions. Okay, so the primary goal of a CAM is to create a faster, more efficient and more precise production process. So the goal of the CAM is to create whatever the production manufacturing that model you are doing, that should be fast and efficient and it should be precise. Okay, so that is the primary role of the CAM. So moving on to next slide, what are the benefits of CAM? What are the benefits we have? So now you can see here the improved accuracy. So accuracy is going to improve. Say for example, if any person is doing it manually and if the machine is doing it automated in the automated way, so the precision or accuracy will be increased. Okay, so it will increase the accuracy and increase the productivity. So it will be faster. Okay, productivity is going to fast. So if any person is doing one model in 1 hour, so the machine is going to do it in a half an hour. So it is going to increase your productivity and reduces the wastage. So whenever it is done in manually and if there is no CAM input is given, then the wastage will be more and it is going to reduce when you use CAM and input the details in the machines. Okay, and enhance the safety because there is no interaction with a manpower when it is working. Okay, so entirely everything will be done in with the machines, so the safety will be more. Okay, and consistency will become, obviously the consistency of the whatever the models that you are doing, that will be more. Okay, so now what is consistency? Say for example, if a man is doing any of the shaft or anything, so between if he has done two parts, so there will be a slightly difference between the two parts when it done in a CAM and when it is done in a machines, then the consistency will be there. The difference between those two parts will be very less. Okay, so that is the greater consistency we will have in the CAM. So next is going to be what are the steps involved in CAM. Okay, so CAD model. So as I said earlier, the first input for our CAM is going to be 3D model. So it is not necessary that the 3D model is created in the NX application. Maybe in any other application or SolidWorks or Creo, any application whatever you have created, that you can just import into your NX application or computer aided manufacturing application, and you can able to create the CAM. Okay, so the next step is going to be toolpath generation. So once you import, you are going to create a toolpath generation, and whatever the path that you create, based on that the cutting tool is going to follow. Okay, so the next step is simulation. So whatever the toolpath that you have created, it is going to be simulated in the CAM itself, and then it is going to check the potential collisions and or errors before going into physical machining. Okay, so the next process is post processing, where it will verify the tool path whatever it is generated, and it will be converted into G codes. Okay, so which are read by the CNC machines. Okay, and then finally the machining will come. Then whatever the G codes that is generated from the post processing, that will be given as an input for a CNC machine. Okay, so that will be given as a input for a CNC machine. So that is going to be read by the CNC machine, and it is going to perform all the operations such as milling, turning, drilling on the raw material, and by end of the CNC machine execute the manufacturing operation, your product will be ready. Okay, so this is about the introduction of CAM. So in the next video, I'm going to tell you some terminologies that we are going to use for NX CAM application, so that it will be easy for you to understand how NX CAM works, and terminologies will be differs from one application to another application. When it comes to terminologies, I'm just talking about NX application. Okay, thank you guys. Hope we will meet in the next tutorial. Thank you.